Yeah. All right. So get the bases the same. We multiply the exponents. That's 3 to the 4x is equal to what? Yeah, 3x minus 3 is the exponent on the right-hand side. Our equation that we want to solve, 4x equals 3x minus 3. And we just solve that equation. Once the bases are the same, the exponents are what you set equal to each other. If the bases end up, if you can get the bases the same, you set the exponents equal to each other. All right. So that's going to give us 1x, or just x is equal to negative 3. Really easy answer on that one. Not bad. Pretty nice. Let's do another one. (81) to the 3 minus x is equal to parentheses 1/3 to the 5x minus 6. Do what now?
You do stuff like this.
Well, yeah. All right. Now.
If you put 81 into 1/3.
Not quite.
1/3 of that.
We want to think base here. So think what 81 turns into to doing. And one of the ways, if you don't know the number for 81, do a factor tree. It's 9 squared, but 9 is 3 squared, right? Okay, so I could get 81 to be a base of a 3. It's actually 3 to the 4th power. And that could be done with, a factor tree for that. It's 9 squared, and y'all did this. The reason I want to go to a 3 is because the 1/3 over here. Right. But what's the exponent? Why? That's right. But why? So when you flip that, that becomes a -1 exponent. And so I'm going to write that step in between what you're saying is the right answer. So that step in between is that 1/3 can be written as 3 to a power. It's 3 to the -1. And then you've got the 5x minus 6 out there. And McKenna said that would be -5x plus 6 as the exponent, which is correct. But this is the step in between that makes that happen. So anytime you got a fraction over here, think negative exponent. That's what you want to do.
You can change that -1 when you change 5x to 6.
It would change both of those. So you'd have 3 to the -5x plus 6, or you could do 6 minus 5x, whichever way you want to do that. On the right-hand side, what are we going to have? Yeah, 12 minus 4. Yeah, 4 times those 3 and that x. So, and now what's our equation? Yeah, and then that's a pretty easy equation to solve. So let's do that. I'm going to add 4x. I actually should just add 5x and subtract 6. So 6 is equal to -1x. X is -6. So anytime you see a fraction as a base, you're going to think, I bet it's something to do with a negative exponent. That's what you want to think here. All right. So let's think about well, D, 32 to the x power is equal to 1/16 to the 3x minus 2 power.
Is 16 squared, so you can change that base. Right.
Okay. So Jordan says that 32 16 squared? It's 16 times 2, so not squared. But let's start with that. 16 and 2. And that's 4 and 4. That's 2 and 2. And that's 2 and 2. So 32 is actually 2 to the 5th power. 16 is really 2 to the fourth power, but since it's 1 over 16, it would be 2 to the negative 4. So fraction in there, we're thinking negative exponent, so we're just going to take that denominator and say, okay, what is that? It's 2 to the 4th. 16, it breaks down to be 2 to the 4th power. Since it's a fraction, we're going to make it a negative 4 and then distribute. So we end up with this equation, 5x is equal to negative 12x plus 8. Is it okay that I skip that step in between there? I'm good with that. Because those two bases are going to go away. And then we just work that out. So that's 17x is equal to 8. Do that by adding 12x to both sides. And then divide by 17. And we get a fraction as an answer, and that's quite okay. It doesn't end the world. It actually keeps it going. If we didn't have fractions, there'd be a lot of stuff missing. Those are fractions. They're portions of meters. 1/100th of a meter. Actually, it would be the rest of the world. The rest of the world is on the standard scientific units. We're the only country on customary units. Feet and inches. I don't know. There's been several attempts to change America to standard units, and standard units is like kilometers, meters, and kilometers per hour instead of miles per hour. You know, every car you buy has that in there, but in American cars, the miles per hour is bigger, and the kilometers is the smaller ring inside of the speedometer. With in a European car or a car that's built to be used in Canada, the kilometers is the larger thing there. So and they use liters instead of gallons. So it's a whole. Well, we're the only country that uses customary units. Everybody else uses.
Two other third world countries.
Yeah, so they don't count. I mean, really, they don't. I mean, in the grand scheme of things, as far as major trade and all that stuff. All right, so let's look at one like this: 4 to the x is equal to 11. 4 to the x is equal to 11.
Okay, 11's prime. Okay.
Right. So getting a 2 is the base. You know, we know 4 is a 2.
Okay, you can do 44. About 1.
No.
Yeah.
Well, it doesn't do you any good, okay? Because you can't get the base the same. As Jordan said, 11's prime, so we know it's not going to break down. 4 would break down to a 2 squared. Yeah, 2 to the 2x is equal to 11. But that doesn't work as far as setting the exponents equal to each other because they don't have the same base. So this is where the logarithms come into play and that they're a useful operation, okay? So the way you would want to solve this is to get rid of the base 2. What log will get rid of a base 2? Log base 2 will get rid of a base 2. So that's what we're going to do to both sides. We're going to take the log base 2 of both sides. And that's going to leave us 2x is equal to log base 2 of 11. This is a decimal number. This is a number. It looks like gibberish, but it's a number. Okay? All we got to do is get x by itself. So what do we do to get x by itself? Divide by 2. So we get x is equal to log base 2 of 11 divided by 2. I want us to get this is the exact answer. Let's get a decimal approximation for that. 3 decimal places. So with your calculator,
How do you put in the base?
I'm going to show you. As soon as my calculator opens. I forgot to have it open. I'm sorry. Mr. Unprepared I am. You know. All right. So how do you get it to do a log base 2? You go math, press the up arrow to find this little thing called log base. Click enter. And it gives you a place where you can put a base 2 and the 11 there. I'm going to get that answer, and then I'm going to divide it by 2. And
1.729.
1.30 if we're going to round it to 3 decimal places. 1.730. This would be our answer. Exact and decimal approximation. The key to doing these types of problems is knowing that to cancel a base, you use a log with the same base. To cancel a base, you use the log with the same base. All right, so let's look at, whoa. Let's look at, I go to another page. Example F. Yeah, we have 13 examples total today, so counting them down. Oops, sorry. Don't put the log in there yet. 7 to the 9x is equal to 15. So first thing you should try is to get the bases the same. That's what you should try first because that's the easy way to solve it. But 7's prime, 15's not prime, but it won't break down to be like 2 to the 4th or anything like that. Okay, so we know we need to get rid of the base that has the exponent with the variable. So what log are we going to use to get rid of that? Log base 7 to get rid of the base of the 7.
So you put log base 7, 9, 8 equals 15, or log 7, 15.
All right, here's what happens. This log base 7 and this 7, they cancel each other out. Okay, that's what we're doing is we're canceling this base of a 7 out so that we only have the exponent left. Yes, ma'am. Yes, it could. Yes. They become 1, basically. These cancel, and we have 9x is equal to log base 7 of 15. How do we get x by itself? Divide by 9. Really simple there. This is not, like I said, I told you guys when I told you we were going to do this after the end of course. This is not hard stuff. It's not. Yet. I always say that. I have to.
Okay, you said the 3 decimal points, so would it be? I got 0.154.
Okay. Math.
So it'd be 1.155.
All right, so log base 7 of 11 divided by 9. 0.137.
It's 15 already.
It's 15? Okay. Sorry. Thank you. That makes a large difference. Enter. And then divide by 9. And that does. So it would be 0.155 is what it should be. You look at the number after the 4, and it's a 6, so that means go up 1. So that makes it 155. Mm-hmm. Example G. 9 to the x power plus 6 is equal to 41. One more step. Mm-hmm. Good. Get the variable part by itself. Subtract 6. 9 to the x is equal to 35. Not evenly. It doesn't matter if it can or not because that's an x is an exponent. So I can't divide by it.
So you mean we need to do log?
We could. All right, so I'm going to break down the 9 into 3 squared. So that's 3 to the 2x is equal to 35. And then do log base 3. That's going to be 2x is equal to log base 3, 35. Divide by 2. Log base 3, 35. All divided by 2. And we're going to get the decimal approximation for that. Okay. log base 3 of 35 divided by 2. Now, I broke the 9 down into 3 squared. No, you can get the same decimal approximation using log base 9. You just don't have to divide by 2. That's okay. But understand that when you go that log base, what I've got written here is 1.3 whatever, 1.618. 618. That's the correct decimal approximation. Understand that that's also equal to log base 9 of 35. And that's what you did to get the answer. And they're the same answer. This and this are the same. Okay. So depending on where you do the log at, how your exact answer will look. So if we have a multiple choice type situation on the test, and this is an answer choice, and that's not an answer choice, but you did it that way, check your decimal values, because they're going to be the same decimal value. Okay. All right. Dun-dun-dun-dun. Now let's get to the logarithmic equations. So those have been exponential because the variable was in the exponent. That's where we've been at. Logarithms are not that much more difficult. To get rid of a base, we used a log. To get rid of a log, what are we going to use? A base. That's exactly right. So they're inverses of one another. So that makes it easy. All right. So let's start with an easy problem. Let's say we had log base 5 of 4x minus 7 is equal to log base 5 of x plus 5. Okay. They have the same log on each side, which is good, because that means the same base is going to take care of both of them, right? Yep. So what base are the logs? So I'm going to use 5 as a base to get rid of that log. So I'm going to make 5 the base. And the way I write that is show that operation that's happening is I write 5 with the little caret symbol. That tells me that 5 is the base. And what happens is this cancels each other out. And all you're left with is 4x minus 7 is equal to x plus 5.
So you're going to have to write down 5.
On that problem, you don't, because there was a log on each side. We're going to get to them in the next example where there's not a log on each side. Then you would, we won't get to any of those in this class. The thing to do would be rewrite them in exponential form and then work with it from there. And you would end up, like if it was log base 5 and a log base 3, you would need to get them in exponential form and then try to turn it into like a log base 15 problem, because 3 times 5 is 15. But we won't get to anything like that in this class. Actually, you don't even get to anything like that in college algebra either. That's more of a calculus level type thing. So, all right. So we set that equation up, solve that thing. So add 7, subtract x, 3x is equal to 12, x is equal to 4. We need to check all of our answers on the log problems, because we cannot take the log of a negative number. So be careful of that. So we just want to make sure that we don't get a negative number in either of those with a 4. 4 times 4 is 16 minus 7. That's a positive number. We're okay. On this side, 4 plus 5 is 9. That's okay. We cannot, if we have a log of a negative number, we throw that answer out. So that's why you want to check it. You don't usually throw one out when there's only one answer. We're going to get to some of them that have more than one answer. You get that extraneous solution that happens. All right, so let's look at this one. Log base 4 of 5x minus 1 is equal to 3. So this gets to what Jordan was saying. Well, you really didn't even have to write those 5. True, on that previous problem we did. But on this one, we don't have a log base 4 on each side. We have a log base 4 on one side and then a regular number on the other side. So we need to get rid of this log base 4 over here. So what base do we use to annihilate that guy? 4. So 4 is the base, but it's the base on both sides. So on the left side, the log, that's right, there you go. The 3 becomes an exponent. And the log base 4 and the 4 on the left side go away, and you get 5x minus 1. On the right side, you got 4 to the third power, which is 64. And then you got an easy problem to solve now. Add 1. 5x is equal to 65, divide 13. If we check that, it does get us a positive number in the log, so it's okay.
Okay, but that's only one out, and I'm just trying to figure out why you put that forward. I mean, I know you got like 4 for a thing, but why did you put it on that side?
Because it's whatever I do in an equation, if I do something on the left-hand side, I got to do the exact same operation on the right-hand side. So here I use the base 4 to get rid of the log base 4. So on the other side, I got to use the base 4 on whatever's over there. Since it's a 3, now that's 4 to the third power.
And that equals 60.
And that's where the 64 comes from. Okay. J. Let's do log base 7 of 3x minus 2 is equal to positive 2. Good. Base is 7. And if you think about it, guys, this is just rewriting it from logarithmic form to exponential form, which is what we did the very first day that we did logarithms. Is that the base is here, the exponent's there, what it's equal to is over here. It's just rewriting it, but we're using the math operations to do that. Caleb, could you please put the phone down? I know nobody's ever taught y'all etiquette on that, but add 2, 51, divide by 3, and x is 17. Again, you want to make sure, check that in the original problem. Make sure you're not taking the log of a negative number. You're not on this one, but you want to check that every time just to make sure. Get in that habit because it's about to matter. Right. So far, nothing just extremely strenuous. Let's look at the problems that incorporate what we've done the last couple of days with the condensing and expanding properties of logs. So let's go over those real quick. If it's 2 logs that are added together, what's that turn into? Multiplication. If it's 2 logs that are subtracted, division. Okay, so those are the rules. And then the exponent down in the front goes up to the top. That same those properties are the ones we're going to use when we're doing this. And then we're just going to get rid of the log. So we're going to try to get it into one log and get rid of it. Okay, using the base like we've done the last few problems. All right, so let's look at this one. Let's say we had log of 2x plus log of x minus 5 is equal to positive 2. Example K. What base is that log? 10. When it's not written there, it's a base 10. And if you want to write the little 10 there, you can. Now, on the left side, there are 2 logs. On the right side, there are none. So we need to condense the left side so that there's only 1 log to get rid of. What does that condense into? Yeah, it's 2x times that stuff. So it would be 2x times x would be 2x squared minus 10x. And that's equal to 2. Now, we have a problem similar to what we've been doing where we only have 1 log on one side and a number on the other. How do we get rid of that log? 10 is the base. 10. So left-hand side, we got 2x squared minus 10x is equal to what? 10 to the second power would be 100. All right, that's a quadratic equation. So to solve it, what's it got to be equal to? 0. 2x squared minus 10x minus 100 is equal to 0. What could we do to make this easier? We'll do the x method, but let's divide by 2 first because everybody's even. That'll make it easier to do the x method with because we get smaller numbers. So divide by 2. X squared minus 5x minus 50 is equal to 0. And then x method would be a good way to do this one. I think this one factors really well. Okay. You can do quadratic formula if you want to. It works too. You get the same 2 answers. We're just doing factoring. So you did what? Negative 10 and 5? Is that what you said? All right, so that's x minus 10. So let's look at that. So you got x minus 10 equals 0, so you get x equals 10. X plus 5 is equal to 0, and x equals negative 5. Now, it doesn't necessarily matter that the answer is negative 5. It's when you go back to the original problem and plug in, are you taking the log of a negative 5? You don't always throw out the negative answer. You do a lot, but you don't always. So it's all based on going back to the original problem. So if we go back to the original problem with the logs, if I plug in a positive 10, I get positive numbers inside of the logs, and that's okay. If I plug in the negative 5, I get a negative 10 right here, and that's enough right there to throw out the negative 5 as an answer. Okay. So this one it's an extraneous solution. It's extra. That's what extraneous means. Extra. So we throw it out. Not too bad. I lied to you. We're only doing 12 examples. Throw that other one out because it doesn't work. All right, last one. Some of them. Hey, you take enough math classes and you do enough of these over the course of your life, you can do them. The log base 4, x plus 12, it's log base 4, plain x equal to 3. So we know right off the bat here that if we get a negative answer, we're going to throw it out because it'll automatically give us a negative inside of the log. So we won't even have to come back and check. What do we do? Well, how's it condense? It comes together in multiplication, so it's x times x plus 12. So it'd be x squared plus 12x with the log base 4. The log doesn't change there, just the stuff inside that we're taking the log of. And since it's addition, we're multiplying.
Okay, so we can do the 4.
Now we can get rid of the log base 4 with the 4 as a base. So the 4 here, 4 here. We get x squared plus 12x is equal to 64 this time. It's x squared, so we get it equal to 0. Factor it. Negative 64, 12, the 16, and negative 4. X plus 16, x minus 4. So you get the answers x equals negative 16, x equals positive 4. And we throw out the negative 16 because it gives us a log of a negative number. We can't do that. These are not The majority of these are not going to be too strenuous of equations once you get the bases the same or get rid of the logs. You'll get to the quadratics, and those are going to get you somewhere with that, okay? So let's look at what we're doing for the next couple of days, or at least the rest of today. Excuse me. And then on page 519. Numbers 3 through 43. Just start on all of those. We've got time on Monday to work on those too. Okay. So there we go. Solving equations. Start with number 3. They progressively get more difficult as you go down the page. I mean, that's the way they're supposed to anyway. Okay.